Hey guys, welcome back to another Works Plus Grinder Series video. You think things are full swing on the grinder right now. As we have told you previously, we're going to be unveiling the new grinder at the World of Concrete this January 2025, Las Vegas. So we've got a lot of work to do, hence we're still setting out the booth layout right now in preparation. Now, today, Tim and Hayden are going to be talking about all matters head. That's what we're going to be covering. They're going to go full geek on everything to do with the head. Gear ratios versus pulleys versus gears versus chain drive versus belts, you name it, bearings, the whole lot. They're going full deep dive on head design, and they're going to be showing you some of the new one. I'm really looking forward to this.
So Tim, Hayden, what are we doing today? There's a lot of things in front of me here.
There's a few parts here.
There's
a few parts. If looks like something's exploded.
Exploded view? Yeah, good at that. No, I mean we've covered a whole lot of stuff recently, and there's not much left of the machine to explain. So, but I think it's a big one, isn't it? This is a major component. You know, if you've got the brains, this would be the brawn, right?
Yeah.
You know.
Yep. For the past 2 weeks, past two episodes, we've been talking about wheel drives, we've been talking about radio controls, we've been nerding out on that, and I've done my best to make it look like I've known a little bit what I've been talking about. And
does that mean it's my turn to...
But this is the part that I'm a bit more excited about, because
that it is.
We're going to talk about the grinding head today, which is the actual, it's where the rubber hits the road, really.
Right.
It's the everything else. This is the heart of the machine, right? This is the muscle. This is the bit that gets the job done. Right?
It's doing the hard work.
Everything else we've been talking about is really a support act to the grinding head of the machine.
That's right.
So the grinding head's where the diamonds are attached. It's the bit that's got the weight. It's got the power. It's what's actually in contact with the floor, right?
Yep.
Everything else is just helping that thing
That's right.
stay there and be moved across and change speed and direction in the way that it needs to be for the application. But at the end of the day, this is the heart and soul of the machine, right?
It is. So, I mean, I've helped design this, and I don't recall seeing this in there. So,
I think that's just one of our workout tools around here. Workout Wednesdays at Works Plus.
Nice. Same space gets used, yeah. I guess you've got a lot of older generation parts.
We do. We've got a few bits and pieces from the, let's call it the existing.
Yep.
Not the existing, the old. Well, the existing, the Gen 1 machine that we manufactured back in King Concepts. So basically, a machine that was designed, let's call it 97, 98, and probably the first five production machines I think we built in 1999, if my memory serves me correctly. So not much change in those machines over the period of sort of till 2010.
Yep.
So let's call that a decade. They were pretty much all made the same. Even further on when they became a radio control, I think that was around 2014 or something like that. So essentially up to when they stopped being made around 2019, something like that. It was basically the same machine. So we're going to be talking about a machine that was made in a particular context. So it was in the early days of planetary grinding machines, and we've talked about in previous, not so much in the grinder series, I don't think, but some of the podcasts, we talked a bit about the history of the industry, about how it originated from smaller planetary machines, passive planetary machines, mainly used for wet applications. In fact, exclusively used for wet applications, natural stone terrazzo, that sort of stuff. And really how this evolution to bigger, larger commercial, industrial grade machines, much more higher powered, and obviously being deployed into different types of applications altogether. Grinding concrete, dry, surface preparation, harsh environment. So really demanding environment to make a machine. So that's a quick rehash of that of the history.
Now I guess King Concept machines.
Yep.
What were the main differences to the machines before that? Like, I mean, I see a lot of machines come in that are top drive belt driven. Some of them are, no active planetary. What was the predominant machine before that?
Well, the passive planetary machines were the only ones available on the marketplace. So I think HTC brought their range, the 800, they called them the Dynova 800 and 650, I think, and the 500.
Yep.
That was their entry into the marketplace. That would have been around 1990, 91.
Okay.
So they had previous experience with passive planetary machines. I think there's a machine at the time called a Cymex. Still around today, still used in, I think, the carpet cleaning industry. Okay. So the original owners of HTC came from that janitorial cleaning maintenance background and had exposure to the Cymex machines, passive planetary. So really their contribution was to control that planetary, get it away from a passive to putting that top belt, which sort of restricted or held back that planetary a little bit.
Start harnessing that power.
Yeah.
That 3 kilowatts that they had.
So I guess, look, their focus was obviously to change the productivity of the machine by controlling that planetary head. So they weren't thinking about dust and concrete and polishing and surface preparation, all that kind of stuff. The paradigm in which that machine would have been created would have been based on their experience, which was predominantly wet application, terrazzo, natural stone, that sort of thing, and trying to do something about that passive planetary and harnessing, I guess, the power in the big head of the machine and controlling that, so we're getting more friction happening at the discs. So that was a massive step forward, but obviously being designed and conceived in that paradigm, it wasn't really made for the sorts of applications that people are using the machines for these days.
It was fit for purpose for what they needed.
Absolutely, and a massive step forward at the time.
Yep.
Okay.
And then you guys came along.
We did, and I think we've covered that in the previous podcast as well, but clearly our desire was to make something more powerful and more robust and more resilient to the rigours of...
Fit for purpose. Seems to be a common word in all of our things. Everything has to be fit for purpose.
Fit for purpose. But again, our paradigm was still very much limited to previous experience, and our previous experience is really 2 machines, which was the Tornado, which is a passive planetary machine from the UK, and the HTC product. So as far as our, let's call it our reference material or our benchmarks, it was still very, very minimal. And our machine was still, let's call it, based on what we knew was the Achilles heels of the things that we've been using, okay? Clearly, 25 years later, as the industry's continued to evolve and I guess the expectations of machine have changed, the applications have changed, the tooling's changed, there's so many things that have changed, and over time that exposes other Achilles heels, and clearly there are some weaknesses with the machine that we made 25 years ago. I mean, let's face it, we're not engineers. We never were, okay? It was very much made in a trial and error framework.
That's right.
And we've sort of been trying to play catch up.
Ever since.
And we've learned a lot, and I guess that's probably what we're going to talk about today, some of the things that we've actually learned, some of the things that we've observed, because our machine didn't change for, 25 years ago was the last time we actually made a machine, really. And other manufacturers have come into the marketplace. Existing manufacturers then have brought out
new machines.
I think HTC brought out 4 different series in that time. So there's been progress, and we've sort of been sitting on the sideline looking at all these things. We've talked a lot about our service department, our workshop, and all the different things that come through. So we've got the inside eyes on other platforms and other attempts to create a right solution for the industry.
That's right.
So we've been absorbing. We've been doing a lot of absorbing, and
that's it.
The wheels keep turning. So let's talk about some of the, I guess some of the let's call it some of the Achilles heels with the first machine,
the Gen 1s.
Yeah, because really what we're trying to do here is, we're kind of, apologising to the industry a little bit in some ways, because we know some of the pain. As good as the machines were, we know some of the pain. We were responsible for it, and we're going to take care of it. We're going to make that all better again.
That's right. We're going to make it go away.
We're going to take that pain away. So this is kind of like a bit of a confession.
Yes. Well, I guess from the service side of it, coming through, it's just a handful of parts here that we're going to go through. What some of the challenges, I guess, in the Gen 1 machines are, Some of these have already had some fixes done in different upgrades that we do as well. So when we talk a lot of the big block machines and things like that, you'll see that's with the 15 kilowatt motor on the 680s and 820s. But yeah, some of the technologies we've already adapted to and tried to solve some of these problems on some of our upgrades. So I guess let's start with this one. It's the easiest and first up that we can start with.
Well, and it's not only that, it's still a problem today.
It is, on many machines.
On many machines, even some of the newest machines that we're seeing in the workshop, we're still battling the same problem when it comes to the drive motor and the what we call the centre drive pulley.
So what a lot of people probably don't know, when their machine comes in for a rebuild, one of the mechanics, they can spend anywhere from half an hour to 2 hours trying to get this particular part of this right. The centre drive pulley mounts straight on top of the motor shaft. Now, if the surface underneath that, it's probably stuck. There you go. So that surface on the top of here seats into the bottom of that. Now, if this surface is off on an angle, what it actually does on an exaggerated view is this centre drive actually starts sitting off. And when it spins around, it gets a big wobble on it. And there's only a very fine adjustment that we allow as a tolerance for that. So having that, whatever movement is sort of down here, gets exaggerated once it moves up. So a lot of time when you find you've got a nice vibration going on in the machine, or you've given something a bit of a hit, and all of a sudden you've got a vibration. A lot of the time, it's this centre drive has just moved, and it's the tiniest amount. Like I think it's 0.02 or 0.05 according to the user manual, but 0.02 or under is what we aim. Well, we aim for 0.0, but 0.02 and below is acceptable, which is the tiniest amount. Like we're just nicking the surface with an angle grinder blade to get these changes. So what have we done to fix this?
Well, we have...
I think it's over there, actually.
We have... I'd like to just pick up on one other thing too, because when it comes to not only is this system where we have the centre drive pulley straight off the shaft of the motor a problem from, it accentuates any run out in that motor shaft, and that motor shaft can get a bit warped over time from temperature. We know that these motors on most of the machines, they're running often in their maximum or above current rating. So that creates a lot of internal heat, which can cause a bit of warping and distortion in the spindle. So over time, even though that shaft is supported by bearings at both ends, it should run perfectly concentric, but with this heating and cooling that goes on, you can get a bit of run out. And like you're saying, this accentuates any run out. And we'll explain why that's a real problem when we talk about the shell of the machine in a second. The other problem is it gets seized on the shaft, right?
Yeah, this one didn't come like this.
No,
I had to work on this.
This is a rarity. This is actually a really bad fit. But a lot of the machines that when they come in for us to do a pull down, a tear down, and a rebuild, one of the first things we have to do is actually get this shaft off this motor
while it's in the machine, not on a bench like this.
And because there's so much contact area on the sides there, that can seize over time. It can get a bit of moisture in there. It can sort of rust up inside there. And I actually thought when you started saying it could take between half an hour and 3 hours, you were talking about trying to get those things apart.
No, that's the first job.
Getting those apart, we've had machines where we've actually had to literally cut the shaft, break the flange of the motor, because that thing was so seized on, we just couldn't pull it off with a really strong hydraulic pull of the whole lot. So having this connection where the motor drops down into the centre drive pulley can be really problematic sort of a year down the track, 2 years down the track when it comes down to some major service work, just getting the bloody thing apart, right?
And we're not just talking this series of machine as well. So this series of machine is the motor, and generally the machine gets popped open and this gets removed off the motor and the motor is taken out later. A lot of the other manufacturers actually have the motor as the first thing to come off. So we're not even looking at this, we've just got an aluminium flange with crowbars trying to lever this out of a part that's stuck inside the machine, which is another problem again. So, and quite a lot of manufacturers have that.
So we've introduced a coupling. Cut to the chase. So this is it's a coupling. I don't know which. There's probably a fancy name for these sorts of things, but essentially this coupling goes on the motor. Now this was something that we've introduced when we started doing the big block conversions. Okay, we wanted to get away from this whole
Direct attachment.
and all the vibration that can come from that. So quite simply, we put one of these industrial couplers on, and there is a paired piece, that black that sits on top of that, and that's how we get the transmission of power, but we can get the easy separation because basically they just sit in above each other. We have this element which is there for
cushioning and wear and tear.
So that becomes the wear item. It makes it quieter as well, and it just allows it that little bit of freedom and flexibility. So we don't get the vibration, and we can get really easy separation. Correct. So even though we've gone to a 22 kilowatt motor that is, I think we showed in one of the previous episodes, that was 50 kilos lighter than the conventional induction motor, 22 kilowatt. We still want to be able to pull that motor off at our
just one-handed,
our leisure, and by having this coupling system makes it very simple to take that motor straight off without having to worry about any alignment issues and so forth. But also very easy to install it, and from a service teardown point of view later on in life,
much quicker.
We're not going to be spending hours trying to get these two pieces apart.
Absolutely.
So
it sounds great already. I like it. Where to next?
Probably we should talk a little bit about the shell. Because we're talking about vibration, and a big part of that vibration comes from the conventional system of manufacturing a shell. And so this is part of the shell. And most manufacturers, even a lot of the current machines being made today, are still got this shell construction method in one way or another. And essentially what it is, it's a sidewall with a plate across the bottom and a plate across the top, and it contains all the working parts in between. So in the case of our former product, we would have this big motor mounting plate, and that would sit essentially up here on top of one of the plates. Okay, and it would be turning in that.
So you'd have two bearings fitting onto this boss into another housing that allows the barrel to rotate while the remainder of the machine sits still.
But the problem is that with the motor sitting on here, there was a bearing housing on the end of this centre drive pulley that was located in the bottom plate. So whenever this centre drive pulley wanted to start vibrating, it was basically sending the vibration through the whole grinding head because it was connected to the top and the bottom part. Plus it didn't have this coupling system, the whole lot. So anytime you started getting a bit of vibration, it went through the whole machine. So it wasn't just affecting the bearing on the end of the shaft, it would start affecting the bearings in the pulleys, the idler pulleys,
start affecting your floor.
And it would translate through to the floor at the finish as well. So the shell construction, that was one problem with the shell construction. Anytime you get it run out of vibration. Another part of the shell construction is that to access parts inside, you have to do a fairly major amount of pulling down to actually get inside and have a look and check for things, okay? Because we'll probably just talk about this fly pulley. So this was the original pulley. This is a pulley out of a 680. So that sits up behind all the grinding heads. And you can see there's a pulley, a bearing on one end, and then there's a bearing on the bottom. So these pulleys are all supported by the top and the bottom, okay? And of course, one end was located in one plate, and then the other end was located on the other side of the shell in the other plate.
Sounds great, twice the strength. There's a downside?
Well, the downside is these shells are quite complicated things to manufacture, particularly given there's a lot of welding in them, there's a lot of fabrication, and that can create distortion. So when you've got a top and a bottom plate and you want them as parallel to each other and as concentric to each other as possible, any small margins of error in manufacturing the side wall and the shell will mean a misalignment in those pulleys and shafts, because they're both resting in either the top or the bottom plate.
Correct. I can contest to that. I've helped build some of these, and yes, difficult to get right.
And of course, the other thing is this whole shell has to spin around, and if there's any
ups and downs,
up and down in the side wall, well, as the heads are going around, there's a little bit of this sort of thing going up and down in the machine as well. And of course, any misalignment in pulleys, and we're not talking about belts, we'll get to belts in a minute, running a flat belt means you get runoff on the belt on the actual pulleys.
So essentially what that means is that if a pulley is held top and bottom and the top plate is misaligned, it's exaggerated, but angling that, which then if a belt is running on there, it's going to want to track up, which is very similar to when the bearings wear out in these. They get a similar problem, that they allow this pulley and shaft to twist a little bit and allow that runoff as well. So yeah, trying to, part of the tracking is we're basically twisting these plates left and right as we're doing everything up with urethane and everything wet, ready to go, which in summer's about 10-15 minutes before it goes off. So it's a real rush to get them in, but that's a fun task to do.
Well, it's a bit of a nightmare for a mechanic. It's not even particularly fun when you're making the machines from new, because there's always a little bit of apprehension. Am I going to be able to get the belt to be able to run properly this time? But certainly from a rebuild, reconditioning point of view, it's just an ongoing issue that needs to be right. And if you don't get it right, like you're saying, it can create belt runoff. But of course, you need to be able to create some kind of environment where all these parts can be housed, because it's a really harsh environment with all the dust and so forth. And of course, the other big problem is when you make a planetary machine, the additional complexity of making planetary machines, that whole head needs to be able to turn around. So you need to make an environment that encapsulates all these parts and protects them from the dust, yet it can still somehow turn around. And the parts that are actually involved in doing all the turning around,
keeping the dust out of them.
Keep the dust out of in there. So it's
which I'm sure everyone has had problems with dust getting into the inside of their heads. So
so really, all of these things obviously are areas that can create problems for making a smooth running machine, and obviously a machine that's going to last for a long time. So they're all fixable, and they're all you can mitigate all those issues, but it just makes it, from a manufacturing point of view, from an assembly point of view, a whole lot more areas where you can have a little bit of a problem. That means you can't necessarily get the machine running as smoothly or as true as you want to. Okay. Then of course we've got things like the actual
fly pulley,
pulleys and parts and so forth. I mentioned before, we're not engineers. We weren't, and we still aren't. Okay. So some of the things that we manufactured originally were things that just made sense to us. Okay. But we were envisaging these without ever having to pull one apart, right? Or even knowing how. So, I mean, even a pulley like this is still a nice pulley, okay? But there's at least five parts in this pulley. And the process of pulling that apart is quite difficult.
It is.
Talk to us a little bit. You've probably pulled more of these apart than I have now, Hayden.
Well, I don't know about that. So I guess, as Tim said, we've got a lot of bearings that are, like this top bearing, quite hard to get access to. So, you can't just throw it in a vise and smash it out. There's special tooling designed to get in underneath. All of these are relying on Loctite to go on. So you also have a lot of heat that you've got to put in. So lots of different parts to try and get in and around, but you've basically got a bearing to come off your your pulley that's on top of the shaft, and you can press that right out. And then you still have a bearing housing there to remove out of the shaft. All of these have circlips along the way. Then once you get all of that apart, you've got three big pieces, but you've still got to get the bearings out of there and then redo. So there's a lot of cleaning has to be done. A lot of components, circlips permanently getting replaced, and there's quite a few in there. So It is a long process to rebuild these. On average, our mechanics, when they're doing them in batches, they're taking anywhere up to about an hour to strip these out and then put them back together, which doesn't sound like a lot, but as Tim said, there are faster ways to do these things. So
yeah, and obviously they were built to last.
Yep.
Not necessarily built to take apart.
Yeah. Yep.
And it's when you get to that take apart stage that it becomes difficult, becomes expensive. These parts are actually reasonably expensive to manufacture just with the way they've been made, with keys and with, like you said, circlips. And, if one part flogs out, often it can damage another part. And so you're replacing two parts. It's not isolated. Wear is not isolated to one part or one shaft. It can affect the pulley, and now all of a sudden you've got an expensive pulley got to replace as well.
That's right.
Plus, like you said, the amount of force to get these apart sometimes can actually result in damage, distortion to some of the other parts. So, really good part from new, made to last, but when it comes to service and maintenance, not the most fun sort of thing to work on.
Good fun for anyone who's tried, that's for sure.
Yeah. So
okay,
we've tried to deal with that.
Yep.
Should we talk a little bit about how we've tried to deal with that?
This is one of our pulleys, right?
It is. How about you show us the equivalent? Bring this one over here for
Bring this one over. So this is one of the fly pulleys out of the 850. As you can see, it's quite a bit different, obviously two different size machines. So we've made some of the parts. So on this one, the attachment to your demolition head is a part of your shaft. So if your bearing surface wears out, you're replacing the entire shaft. Whereas on this, that drive plate is completely separate. Just bolts straight into the rest of the pulley. So likelihood of having to replace this and this, quite slim. Once we get up underneath, obviously we've got, this is the equivalent in here of our actual shaft. So these are reversed in essence though. So our shaft now becomes a stationary, whereas in that's locked in as part of that.
So yeah, in the past, we would have the pulley suspended by one bearing at either end, and you can just turn the pulley. So you can see that the actual shaft turns with the pulley. Okay.
Yep. Now, I can't hold that like you just did with this, because I'm not that strong. How about we lift the pulley and just turn the other bit, all right?
So now you can see that the actual shaft is not turning with the pulley. So in actual fact, the shaft is now stationary and the pulley just spins around it. It's a little bit like a hub, well, an axle on a car or a trailer.
Correct.
Where the axle stays stationary, and the wheel is just spinning around it.
That's right.
So we've cut down on the amount of moving parts.
Correct.
We've cut down the amount of parts that actually need to move or to achieve the end result. And we've isolated where there might be a failure, if we can call it that.
From wear and tear.
We've isolated in the way that it can only affect one part outside of the bearings, which we know have a finite lifetime.
Correct. Sounds good. I'll take 3. What else? I mean, look, we've done similar systems with a lot of our idlers as well, where it's the same thing. They're not captured top and bottom. Obviously you can see. So we'll get into that a bit more later on as well. So again, quite a lot of changes within compared to the earlier generations that we've done.
And certainly from a dismantleable, if I could call it that, point of view, far easier and far
quicker
quicker to pull these things apart to access key bearings if they need changing over time. So from let's call it a service rebuild time and cost should go down. If you're talking about an hour to pull one of these things apart and rebuild it, I would suggest we could do that, all 3 of them,
in the same time,
quite comfortably in the same sort of time now. So that's a big improvement from not that we're expecting people need to do that often, but it is going to happen.
Absolutely.
Every machine comes to a point where it needs rebuilding and servicing and reconditioning. So that just makes it a whole lot easier and a whole lot faster.
Big changes.
Now, Hayden, I'm looking at this new part and I'm looking at the old part. I'm seeing a very similar pulley surface.
or they're not interchangeable, so don't ask.
And I'm sure some of our viewers will be going, no, these pulleys have still got a flat surface on them, or close to a flat surface.
They do.
So anyone that knows anything about these machines are probably going to know that probably there's a flat belt that runs around that.
If it's not a flat belt,
it's clearly not a gear drive.
Correct.
Right?
No gears, no notches, no nothing.
Yep.
Yes, around here we still, we like our flat belts for numerous reasons. Look, the big reason I prefer to stick with a flat belt is when guys it just gives you a bit of give, right? So if you're going along the floor and there's a giant dynabolt on the ground and you hit it, if it's a geared machine, the amount of impact going through all those gears all the way up to the motor is massive, whereas this will just let one of them stay, the belt might slip a little bit, and off you go and you keep going.
So if we just back up just a little bit, we had several different choices. Obviously, you've mentioned gears. So gears is one consideration.
Yep.
Flat belt's another consideration. We're seeing a lot of poly V belts or micro V belts, whatever you want to call them, in manufacturers, tooth belts.
Yep.
And then tooth belt, like timing type belts.
Yep.
Anything else that we've seen from a drive train?
I'm sure someone's got a chain driven one somewhere.
But that's pretty much,
seems the major.
Certainly when we were manufacturing the original machines, pretty much with every machine was a flat belt.
Mm-hmm.
Then we started seeing a lot more poly V belts and tooth belt or timing belt type things.
Yep.
Let's talk a little bit, and then a bit later again, we saw gear drive machines. And I'm talking about planetary. Obviously the old Turco machines, the STI, Prep Master type machines have always been gear drive and oil-filled machines. But certainly the planetary machines have been dominated by belt drives.
Yep.
And there's good reasons for that, and you've just touched on them. So let's just talk about, you've mentioned gears, for me gears are quite expensive to manufacture compared to a flat pulley. A lot less machining in them. You've mentioned the actual force or the impact that can go through the machine. We're doing so many different types of applications with these machines. A lot of our customers doing floor prep, like you're saying, there's a hidden dynabolt or some sort of steel plate in the floor.
Sitting on a 20mm lip, trying to grind it down.
Yep. All of that, if there's nothing in the system that can absorb or relieve that impact, it's all being borne by the gears. Yep. And then of course we've got flat belts, poly V belts and tooth belts.
Yeah, look, tooth belts are very similar to gear driven in that regard. They you get an impact on one of those, and generally they just snap in between. So, or they'll strip the gears off the drive cog, and you're basically at the same point. So, again, quite a few manufacturers using them, but from the grinding I've done in the past, I'd see that as a problem. Yep. So
let's just go over here and.
Are they still going? Sorry, guys. Well, tune in next week for the next episode where we'll actually be showing you the internals of the brand new head. So excited. See you next week.